schedule, so if you don't mind, I'll start my presentation with that right. Okay? Okay, so I'm Piotr Fusik. I will talk about my own programming language called C. Those of you who are not Polish need to learn a single Polish letter, which is C. If you can't pronounce it, don't worry, you will hear it several times during this presentation. This is your first Polish lesson. This is the Polish alphabet, and as you can see, C is next to C in Polish alphabet. So this is why I chose this letter for my language's name.
It's C++ in Polish.
It's better than C. Let's start with a good question: why another programming language? Because we have already so many of them. So if you ask why, I will answer that with two questions. First question is, can you program in language X on platform Y? And I choose 6 popular programming languages and 8 popular platforms. First one, take C. If you write in C, you can make applications for Windows, OS X, Linux. For Windows Mobile, that's the old version of Windows Mobile. But you want to run C programs directly in a web browser. It won't work that way. On Android, you may write in C, but it's not as straightforward as Java. So I would maybe in this sort. How about Java? If you take Java, you may write Android programs for Java-enabled phones. But if you want to run Java programs on Windows, you have to install Java. And not all users have installed. Some of them don't want to install Java just to run your program. Same for web browsers. You need a Java plugin in a web browser to run a Java program.
So yes means out of the box.
Yes means that you do that and there aren't any problems for the users. Maybe it means that, okay, there is possibility to make it, but users need to download something. It's often several megabytes. They have to spend time installing it, maybe later updating it. So maybe it means it's possible, but it's not straightforward. Okay, so the other options are C#. As you can see, C# is Microsoft centric. There is Mono, but again, you need to install Mono. JavaScript is, of course, for web browser applications. And it is also pre-installed on Windows, so there's no problem programming Windows in JavaScript. ActionScript is actually a web browser technology, but it's losing field for JavaScript and HTML5. So it's not, I don't think it has a bright future. Perl is pre-installed on OS X and Linux. But on Windows you need to install it, and so Perl doesn't run in your web browser. So the idea is simple. What if we could write one program and then automatically translate it to all these languages? This way we could run this program on all the projects. If that doesn't convince you, there's another question. You write a library and you want your library very portable so that you can use your library in different languages. And the current situation is that you can, if you write a library in the program using the library in the same languages, there's never a problem with that. The second pattern on this picture is that many languages can use C libraries, but this doesn't apply to JavaScript. You cannot take a solid C library and use it from a web browser application. So again, the solution is write code in one language and then automatically translate it to the other languages. And then you can use your once written library, and you can use your once written library from the different languages. Okay. So before I started my own languages, or my own language, I thought about some simple solution to the problem. The simplest solution I could think of is use the C preprocessor. If you write code using macros, you can generate code for different languages. Example, variable declaration. In C, Java, and C#, you write int x equals 5. And that's same as int g. That is the simplest. In JavaScript, you write var x equals 5, and in ActionScript, if you want the variable to be typed, you write var x colon int equals 5. So, my idea was make a C header that defines some clever macros that hide the complexity of different languages. So if you write v int comma x equals 5, it will output program in the language you select. You get that? Yep. I will show you the implementation. It is just hash if def Java, hash define v, etc. And it worked. You just needed a couple of macros, not for all the constructs. For example, loops such as for and while are same in these languages. So the macros worked fine. I was able to write a non-trivial program that was written using these macros. It worked that way that if you compile it with a C compiler, it worked out of the box. If you want the Java version, you needed to run the C preprocessor, which generated Java source code, and then you use it this Java source code for the Java compiler. There was only one problem with this approach, which is called reliability. As you can see, this is a very simple signature of a function. The function is called PLPW2013, and the function takes 3 parameters, and I had to wrap the parameters with a macro called P, and then the function with the macro called func, and then private is also depends on the language, so it is also a macro. And the problem with it is readability. So my approach was to make it readable. This required writing a translator, avoiding the C preprocessor. This is short history how it was done. First, there was this C header, which initially only could generate Java. Then there was C# added, then JavaScript, ActionScript. Then I have throw away the C header and made a translator which takes as an input chi sources, and you can generate sources in C, Java, C#, JavaScript, ActionScript, and D. And just a few weeks ago, I've added Perl 5 backend. So there will be some slides about the Perl 5 backend. And there are plans for Perl 6 backend, maybe Python, Ruby, C++. So it's just a matter of writing a backend that generates another language. It's very simple. You take sources written in C, put it into a command line translator called CPL, and then you can get sources in C, in Java, in C#, JavaScript, ActionScript, D, and you can get Perl module. You may wonder why it is Perl module and not Perl script. That's because C has a very limited library, so you cannot even write say hello world because there is no input-output. It all currently works on simple things such as bytes, strings, integers. So the idea is that you write your code in C, which is portable to older languages. But if you want to make a working program, you just write a front end in Java, in Perl. So this is not that you can write full programs in C. Not at the current version, which is 0.4.0. Okay, that's the command line. It's very simple to just pass output file name, and you can choose the target language and dialect. If you don't do that, it looks at the file name extension, and in the first example, it will output C code. Current backends are C with in 2 dialects, and I wonder why there is a C89 here. Anyone knows the answer?
Because on Windows you don't get C99?
Not on Windows, but with Microsoft Visual C++.
Right.
If you take GCC, that's okay, but Microsoft still doesn't support the C99. which has some limitations, such as variables must be defined at the beginnings of blocks. There is no standard boolean type. But if you write in C, that's just a matter of choosing the target. And of course, you can have a standard boolean type, and you can write variable declarations anywhere. And the C translator takes care to translate it to C89. And there is C99 because why not? There's Java backend, C# backend, JavaScript. There's a dialect of JavaScript that's not direct, but just a feature of new JavaScript implementations where you can make, for example, an array of 100 bytes. You tell it that this is an array of 100 bytes, and that has performance implications. It runs faster, it uses less memory. There's Perl 5 backend, and there's Perl 5.10 backend that uses one feature, this feature switch, which I will show you later. Let's start with a short tour about the C language. As you can see, the data types are int, byte, boolean, enumerated types, string, and the first is string pointer, and the second is string storage. For most of the targets, it doesn't make any difference, but if you want to generate C code, that makes huge difference because string is what you cannot modify, and string storage is where you put your string. Same for arrays. You can have just a pointer, or you can have the array with the storage. And same for objects. You can have a pointer to your object, and you can have the object initialized. There's nothing new here on this slide. You already know all the operators. There are no strange operators. Here all work as you are used to. At first I tried experimenting with using different priorities. That doesn't make sense because if you are used to the priorities as they are in the other languages, you write code that okay. So this works as in other languages, but it isn't that simple that cheetahs only takes the source and does nothing with that. If he sees that this is string to compilation, it will translate it to CS call of function strcmp. The Java is method equals. And in Perl, there is a special operator for string comparisons. There is nothing new on this slide either. If you look at C code, it looks very similar to C#, somewhat similar to Java. It isn't anything unusual. It's object-oriented, so we have single inheritance. You can specify base class after the column. There are fields, you can declare constants, methods, and the constructor. Methods can be static, abstract, and virtual, which works exactly like in C#. This is the biggest limitation of C, especially at the current version. There is a very limited set of what the language can do other than manipulating arrays, objects, and your types. There is no input-output, there is no database. It's a very low level. So if you want to implement, for example, compression, that is good because you work on bytes, you work on bits, and this is what can be done. The whole library, this is the huge word for what C provides, is maybe 10 methods total. So the methods can be such as copy this array to this array, take an array of bytes and make it a string, and such. And the important thing is that if you have something in C, it gets correctly translated to all the languages. So if you write in C str.len, it will get translated directly to the languages that are supported. And it doesn't need any runtime. It is translated one-to-one. So if you take a source code in C and translate it to C, that is all that you need. You don't need to link to any library, and this also applies to the other languages. And there are documentation comments which are also translated to the other languages. For example, if you take Perl backend, this G documentation comment will be translated to Polish. There is limited markup. For example, if you wrap code in the backend C, it will appear fixed with font. You can also write paragraphs. You can write bulleted lists. What's unique to this documentation system is that there is no specific markup for parameters. You just write comment just before the parameter, which is different from the other documentation comments I know. There's conditional compilation, which is similar to C# and also similar to C. So you can grab part of code into hash if, hash and if, and it is you can select it at the translation time, because the conditional compilation is evaluated by the C translator. So if you write hash if false, it won't appear in the translation. There are native blocks. Native blocks are a way to escape the translation. So if you write something in the native block, it will land in immediately in the out. So normally you write native blocks in hash if blocks. Few facts about the G translator. It's open source licensed under GPL version 3. It's written in C#. I'm sorry if you are not on Windows, you need to install it. The translator also takes care of naming conventions. So if you write in your code, you have some identifiers, and the convention in G is same as in C#. For example, if you name methods, you name it with Pascal case, which is the first letter uppercase. But if you want a Java code, there's a different naming convention, which is start with a lowercase letter. So the translator takes care of that. If you output Java code, it will start with a lowercase letter. If you output Perl code, it will be a method with underscores in this name. Mutability is a problem which exists in C. For example, if you have a pointer, it makes a difference if you can modify something via this pointer or not. So there's a difference between a const full asterisk and full asterisk. But you don't need to write it in G, because it will look at the body of the method, and it will see if you modify the object or not. If you don't modify it, it will output const pointer. Same for visibility. You don't need to write if your field is private or protected. If you use this field from a subclass, the translator will know that it should be at least protected. There's one exception. If you want something public, you need to specify that this is public. There's a constant folding, which means that if you write 1 plus 2, it doesn't end as 1 plus 2, but it will evaluate it to 3, and 3 will show in the translation. There's dead code elimination, so you write a private method but not call it from anywhere, it won't appear in the translation. There's a small tool called CI-Part, which is you can experiment with the translations. So you write G code in one of the text boxes, and all the translations to the other languages appear instantly. There is no button called translate, just type code and see that all translations. Now some experiences from making Perl backend. I will tell you about how Perl is different from the other languages. So first, you don't have real syntax for for constants in Perl. Do you agree with that? Okay, so there are modules that let you define constants, but from my knowledge that they will eventually just make a stub that returns your constants. Same for enumerated types. We translate enumerated types the package that returns constants. And there's a catch here because you better define constants before they are used. Another catch with the Perl backend is that bitwise operators normally return unsigned results. If you want signed result, a workaround is to use integer. And what's strange about Perl 5 is that the do-while loop is very unusual. There isn't anything unusual if you just type do-while loop. That's unusual if you want to use continue, which is Perl next. In this case, you have to double the braces. If you want to break out of the loop, which is last in Perl, you have to put the braces outside the loop, and it gets complicated when you use continue and break in the same do-while loop, because in this case you have to double the inner braces and you have to add outer braces and label the outer braces with any other one. There wasn't any switch case statement in Perl. It appeared in Perl 5.10. You need to enable it, for example, with use feature switch. And it is not called switch, that would be too easy. It's called given when. And another option is just to replace the switch statement with if and then followed by series of else's. And to my surprise, there isn't much difference in the performance between a huge given when statement and just a series of else's. Okay, so now we can take single code, translate it automatically to other languages, and then run the program. And it's a good question how well it performs. So the program is my children player. You can look at the source code. If you translate this code to C, it runs in 0.4 seconds. If you translate it to D, I don't know if you are familiar with D, that's not very popular language. It's somewhere between Java and C, and it is also very fast. Java is 5 times slower than C. C# is about the same. And there are JavaScript implementations. The Microsoft JavaScript implementations are about 500 slower than C. V8 is very fast. And there is Perl, which is about 200 times slower than C for the same code. That's all. Please visit the homepage of the C programming language. Please drop me an email with any suggestions. Okay.
You are aware that if when in Perl 5 is deprecated in 5.18?
It's deprecated
Yeah.
Yeah.
It will be removed from
completely, but you mean use feature switch or use switch? Because there are different things.
No, both are deprecated.
Oh, okay. Fortunately, there's an option.
Experimental, I don't know if it's deprecated, but status is given experimental.
Okay.
And warning is generated.
Okay, you have an option there to use given when or just a series of LCs.
Can you do a live demo of CPAD? I mean, CIPAD?
Maybe later, because we are
Quite short.
somewhat well late. Okay, thank you.